last time we reviewed what a parabola was in terms of a function. Right now we're going to talk about it in terms of a conic. Now, when I look at a conic, when we first studied it and in the review, we didn't actually look at what the definition was. And usually when it's first introduced, you don't. But we're going to look at that today. So the definition of a parabola is it is the set of all points that are equidistant from a point and a line. Now, this point, I should put this in parentheses. Anyway, the point is called the focus. And this line is called the directrix. So let's get a picture of what's going on here. And for right now, let's just use our basics. So if I'm going to look at y is equal to x squared, it looks something like this. And I'll put it in blue right here. Now, every parabola has a focus and a directrix. Even if we didn't talk about it before, they're there. That's the definition of a parabola. They're equidistant from a point and a line. So I've got some kind of point here, which we say that this is p, the distance from my vertex, and my vertex here is at 0, 0. Its distance is p, so this point is going to be my focus. And on the other side, over here, I have a line called my directrix, often called a big D. So this is my point, this is my directrix, my focus and my directrix. And this distance is also p. So it's going to be the same distance to the focus as it is to the line. So if I'm going to the focus and I'm going to the line, that's going to be the same distance. So the vertex is exactly in the middle, or halfway between the directrix and the focus. Now, what's really special about the parabola is if I draw a parabola, and in fact, if you think about like a dish shape or some kind of satellite type thing, have you ever wondered why it's a parabolic shape and then it's got the sensor right here? Well, a parabola actually has the unique property that anything that comes in, if I shine light or something or light radio waves or whatever that comes in, wherever it hits on this parabola, it's going to bounce it back to this focal point. And if it hits on the side, it's going to bounce it back to the focal point. And it doesn't matter how far I come out, if this ray comes in, it bounces it back to the focal point. So light or reflection or sound waves or signals or all these things, it comes in and it bounces it back to the focal point. So if I put my receptor at the focal point, it actually maximizes the effectiveness of that satellite. And also, if you think about the sound system in a movie theater, where do they put the speakers? Well, generally, they put the speakers on the side and in the aisle. So they would look something like this. And why do they do that? Well, if you think about the movie theater as a parabola, all of these speakers are playing right into that focal point, which then resound around the movie theater. So we actually use this technology and this knowledge quite a bit, whether we realize it or not. But it has that really cool property that it's all being a light or sound or rays, it's all going to be directed to that focal point. So let's now talk about what that is. If my parabola is equidistant to a point and the point and the line, that means I can pick any point on this parabola. So this blue parabola is a set of all points that are on that parabola. So if I grab any arbitrary point on that parabola, let's say this point right here, What it means is the distance from here to the focus is going to be the same distance as from here to the directrix. Now, to me, it looks like this. I drew this line longer. That means my parabola is not a perfect shape. So maybe I need to move my focus up a little bit, or maybe I need to change the width of my parabola. It's because I don't have a perfect drawing here. But we would say that this distance is the same as this distance. Those two distances are the same. If I pick another point, this one right here, now the distance from the focus to this point is definitely going to be longer than the black one, but the thing was, it was the equal distance from the point that I pick on the parabola, so on the blue curve, any point that I pick, it's going to be equal distance to the focus as it is to the directrix. So this line is going to be the same distance as this line. It's going to be longer, absolutely, but it's going to be the same distance to that line. So if I pick this one right here, this is shorter, but notice it's also shorter to the focus. So any point here. And if those two things are not the same, then it's not going to be equal distance. So I have to have that condition, and that condition being of equal distance to the spots, that's what gives me this parabolic curve. All right, so we're going to end this video here. In the next one, we're actually going to derive it using that definition. So don't forget the definition. From the vertex to the focus, we call P, that's a distance, and the vertex is going to be exactly between the focus and the directrix. All right, see you next time.